Hello and welcome to this new video. Today we are going to talk about going from nothing to Doom coming up. So yes, today we are doing Linux from nothing Doom edition. So we are going to do pretty much the same thing as we did for the other Linux from nothing, but do some quick setting, quick modification in order to run a small version of Doom. So we are going to end up with a 22 megabyte disk that will be able to run that Doom version. Now it's clearly not the smallest that I could make it, but I will still point you towards where you could cut down on the size if ever you wanted to make a way smaller version. But that was not really my goal. I just wanted to give you a quick proof of concept of how you would go about doing things. Now for this video, I don't want to run over exactly the same thing that we've talked about in the other video, and I'm also going to make an announcement at the end of this video about where we're going to take the Linux from nothing series, because yes, I'm making a series, but I'm not repeating everything that we've said in the first video. We're going to skip over a bunch of things, so if ever you want in-depth explanation about anything that we're doing, you can go into the Linux from nothing, the first video. We're only explaining the things that were added because of Doom. So let's get started. Let's get started by, of course, creating a directory for our project and getting the latest version of Linux using git clone. We will, of course, enter that directory, use tinyconfig in order to get a small config, and use menu config in order to configure our kernel. Now, it's exactly the same settings as we've put before, so you can just copy whatever I did in LFN, but we're going to add a few feature to it. The first one will be under device driver, graphic support, and we will enable direct rendering manager, DRM. Now DRM is needed to do pretty much anything graphic related, so we will need something to, of course, throw our graphic on the screen, so we will need DRM. Now let's get into DRM, where we will enable the simple frame buffer driver. Now, what is the frame buffer, right? The frame buffer is the simplest way to throw an image or anything on the screen. Now, right now what we have is just a simple terminal. We're only throwing text. It's pretty much the simplest thing that we could possibly have. So we need something to be able to compile an image and throw it to us, and that's the frame buffer. Now the frame buffer is not really used in the modern usage of Linux. We are going to use way more complex systems in order to create our image that will be thrown on the screen. But if you're using some exotic architecture, you may be using the frame buffer in order to run something like X, because there's no better way to do it. But like I said, most people won't interact with the frame buffer at all in their modern use of Linux. Now that we've enabled that, let's just back one step and go into frame buffer device and then enable the simple frame buffer support. It will also enable at the same time the provide legacy /dev/fb, which is needed to be able to manipulate our frame buffer. And now let's go into support for frame buffer device, where we will enable the VESA VGA graphic support. This will give us the simplest driver for our frame buffer. So now we have all parts of the frame buffer, right? We have frame buffer support. We have a way to interact with the frame buffer using /dev/fd. We have DRM, which is kind of the backend that makes the frame buffer possible. And we have the driver, which is the VESA VGA graphic support. After that, we can just exit menu config, do the make J in order to compile our kernel, move our image out of there, and move ourselves out of there. Now we will need BusyBox in order to make this work. Now technically, if I would have worked a little bit more, we would not need BusyBox. If you want a smaller install, you definitely don't need BusyBox, because the reason that I need BusyBox in that install is because the Doom version that we're using needs us to specify where the WAD is. Now, if you don't know what a WAD is, it's going to make sense when we're going to get to Doom, but it needs to specify where the WAD is. And that kind of screws me over, right? Because I either need to change the Doom source code or have some kind of shell there in order to be able to give Doom the information that it needs in order to open. Now I decided to be lazy and just install BusyBox and use it in order to give the argument that Doom needs. But like I said, if you want to make it smaller, you should go ahead and modify the source code just a little bit in order to boot Doom, knowing where the WAD will be. But we have a basic vanilla BusyBox install, nothing changed. Once our BusyBox is installed, we can get to our frame buffer fbDoom. Yes, we're using a special version of Doom for our setup. So frame buffer Doom is a minimal Doom that only works on the frame buffer. So we don't need a bunch of libraries. We actually just need 2, which is really 1 library. So that's really fun because, well, we don't have to run around like headless chicken in order to get what we need, right? We can make it simple. So we are going to use the git clone command. Don't forget the depth1. Well, it doesn't really matter because it hasn't been modified much, but still, let's save a few kilobytes of bandwidth. Let's do cd fbDoom again. Don't forget the caps in order to get into our directory to be able to compile it. Now, this Doom version needs us to have libsdl at compile time. So remember to install the dev version of libsdl 1.2 in order to have all the libraries to be able to compile your frame buffer Doom. Now let's do make so that it compiles the whole thing, and we can move the executable that was created, fbDoom, out of there and move ourselves out of there. Now we have an executable, but like I hinted at earlier, we need some small libraries. Not a lot, but we need 2 of them. Now let's just take a look at which libraries are needed in order to run this program. To do that, we need LDD. LDD tells us all the libraries needed and where to find them if they are on our system. So we do LDD fbDoom, and what we see is that we need the Linux VDSO, we need libc, and we need LD Linux. Now let's just demystify what those are. Linux VDSO is, well, if you've watched my video a little bit, it's the VDSO that is included inside of the Linux kernel. So all Linux kernel, once you compile them, have the VDSO inside of them, so you never need to add a real file because it's always in the kernel. It's a bunch of functions that the kernel gives you that are there to make things a little bit faster. So that's something that we don't need to copy because it's always built into the kernel. Now we have libc. Libc is kind of the base of any Linux system. If you have libraries, you have libc because libc needs to be there in order to run everything. There's nothing that doesn't need libc, right? So we are going to need to take a libc and put it into our Linux from nothing. We are also going to need an LD Linux. Now LD Linux is a bit different and the same thing at the same time because LD Linux come from libc, but its only job is to load dynamic libraries. So right now we have one dynamic library, which is libc, and it will be loaded using LD Linux that is given by libc. So we will need to copy over both libc and LD Linux in order for our program to work. Like I said, it's kind of 2 times the same thing because if we were to compile libc, it would give us both libraries. Now today we're not compiling libc, we're keeping this as simple as possible. So we're just going to copy over from our own system onto Linux from nothing. Now if you would want to get some kind of space optimization, you could compile your own libc, but like I said, we're keeping it simple here. So let's do make dir initramfs/lib in order to do our directory, and let's copy over our version of libc into that lib folder. Now what's fun is the LDD command gives us literally where the libc library is, so we can just copy that line and copy it over to lib. It's done. That simple, right? And we can do the same thing for LD Linux. So let's make dir initramfs lib64 because it's in lib64, and let's copy over that LD Linux into lib64. So now we have the libraries needed in order to run our program. Now we also need that WAD that I was talking about. So Doom itself is really just an engine. It will run whatever you give it to. So we will use a Doom 1 WAD. You can use your own, but as long as it's named the right way, you're going to be able to run it with your Linux from nothing Doom edition. So of course, follow the link in the description in order to download the same as I do. So we download it, we uncompress it, we make sure that it's called doom1.wad, and we can transfer that over onto initramfs. So we are going to transfer both fbDoom and doom1wad into initramfs and enter that initramfs. Now we can do pretty much the same thing as Linux from nothing. We can remove the Linux RC because we don't need it. We can do an init. So let's do nano init. Let's do the shebang bin sh. Let's mount both proc and sysfs even if it's not really needed. And let's do a command that you've probably not seen never if you haven't been in Linux for well, forever, which is make node. Now make node is there in order to populate your /dev. So when you communicate with any device from your kernel to a specific hardware or software device, you will normally need to declare that you need a node in order to communicate with that device. Now Now, normally you don't need to do that because, well, systemd does it for you. udev inside of systemd is there to mount automatically whatever you need inside of /dev, so you don't have to do make node in order to have access to those devices. But right now we have a system so simple, it of course does not have systemd, it does not have udev, so it does not have anything needed in order to make our nodes. Now, just to give you some information, quick added information here. There was some system to do nodes before systemd, okay? I'm not saying that you necessarily need systemd. I'm just saying that in our modern times, if you want to make nodes automatically, you're using systemd, okay? So calm down. Yes, there was a time before systemd and people were still okay back then, okay? Let's not panic about this. So we have the make node /dev /fb0 for the frame buffer, and after that it's kind of a thing that you should just trust and put there and not question. So it's C290. Just don't question it. I'm not even sure that I fully understand it. I know that if you add 32 to number 29, you can do fb1, fb2. Anyway, there's some kind of magic to it. I don't really care. It's magic. It works. Trust me, bro. So then we can do the /fbDoom -iwad /doom1.wad. And at the end, let's just execute the shell. We have a shell. Let's go for it, right? And then we can save that init. And let's just take the time to make both our sys directory and our proc directory, which I forgot in the last video. So now we will have a working sys and proc system. And of course, we can chmod +x that init. So at that point, we're pretty much doing exactly the same thing as Linux from nothing, right? We will use that weird find cpio command in order to make an init ramfs archive. We will compress that archive. We will move that archive right out of our working directory, and we will move ourselves out of that directory to go back to our project root. And then we will go and create our disk. Now, the smallest disk that I could do was 22 megabytes. So if you want to do exactly the same recipe as me, go for 22 megabyte. Now, we don't forget to use fdisk in order to create our disk. And there's a quick change that you guys gave me pretty much 4,000 times. I'm going to put a couple of comments. That's a really good command, okay? That's a really a good one. Sudo lo setup -f P --show. What it does is it actually looks at whatever image you have, it finds the partition, and it also finds the latest available loop that you can choose. So you don't have to do to lo setup, you don't have to look at which loopback device is free, you just run that command on your disk image and it will actually find the loop for you and mount the partition at /dev/loop with the loop number P1. So it makes things way simpler for us. So with that, we can start actually formatting our partition. Now, we will use a slightly modified ext4. What do I mean by that? ext4 by default is extremely expandable, so you can extend it however you want, okay? You can extend it 10x and it will still work. What that means is that when you have really small file system like 22 megabyte, it will create so much inodes that it will actually fill out a great part of your drive. So to be able to counter that, we will actually tell it, hey, I don't want 36,000 inode, I want 500 inode. So we do that using the sudo makefs.ext4 -N 512/dev/your loop device P1. Now, the reason why we need 512 is because Grub itself is about 300 files. Yes, it's an heavy boy, right? Grub is a really heavy boy. Now, 300 for Grub, we add, 2 files up on that, but I still don't want to run out of inodes for any freaky reason. So let's just give it a little bit more inodes. Technically, you could do the exact calculus and give it exactly the number of inode that it needs, but to be honest with you, you should not use Grub in order to make the smallest image ever, because Grub is big as you know what I mean, okay? So Grub is a really big bootloader. If you want to shrink your image down, just dump Grub and use something else. So with that, we can now mount our file system using the mount command. We can copy over our image and our init ramfs, and we can do the sudo grub install command in order to install Grub onto our disk. Now, we also need to add a menu entry entry onto our boot grub config file, and that entry is going to be slightly modified because we will need to add the gfx payload command. What gfx payload tells the system is it tells it, hey, I want a screen that size, okay? Do whatever you want. The screen is supposed to be that size, deal with it. So with that, our kernel will know that it needs a screen that size, thus it will be able to call upon the graphic function of the kernel and enable the functionality of the frame buffer. Because if we don't call gfx payload, it doesn't have a screen size, it only has a terminal, and it won't be able to call upon that frame buffer because there's no graphic framework that has been started, right? There's no DRM. So to be able to enable DRM and all the backend, we need that gfx payload command. And now we should be able to save that and actually boot our system and play Doom. Yes, folks, we're able to play Doom with that simple of a setup. So while I'm playing Doom, let's just talk a little bit about the future of Linux from nothing. I've seen how much you liked the last video, so I want to, of course, make more content so that you continue enjoy it. Now, I gotta say, I made a small mistake starting the series with BusyBox. BusyBox is great for a simple installation of a shell, of a bunch of small utilities, but it also abstracts us to the real working of the kernel. So what I will do is I will restart Linux from nothing. In a new video, I will rename both videos, both this video and the video before, as Linux from nothing beta, and I will create a new lineup of videos, Linux from nothing, which will go to the raw basics. We will compile everything ourselves. We will get our own libraries. We will get our own programs. We will do everything that doesn't require us writing C actually done by us. So that way we will be able to understand fully how things work. Now, I want to address a few little things because I've received a lot of comments from you and I really like them. You have a lot of good ideas. They're all noted down. We're probably going to do all of them and of course continue going on with your comments. I really like it. But a sentiment that I've seen a lot in the comments was, hey, if you're doing Linux from nothing, what's the difference between that and Linux from scratch? And in reality, not much, right? Because Linux from scratch is the same thing as that I do, just with another recipe, right? It's made a little bit different, but it's fairly the same thing. Now, the reason why I'm going for the way that I'm doing it and I'm naming it differently is because I believe that there's a lot of value into having it in video form. So being able to see somebody talk about each software, explain what each software does, and explain where the pitfalls on how to install that software may be. Because of course, I went through it. I know where it can fail. I will tell you where it fell. I will tell you what it does. And that's the actual fun part, right? It's not fun to just follow a Linux from scratch script and just write command, copy and paste. That's kind of boring, right? That's not the fun part. The fun part is understanding what's going on, being able to modify our system, being able to be confident that whatever happens with your system, you understand from A to Z whatever is happening. And that's what I want to do. I want you to be able to understand all the system in your machine, how they work, what's their relationship with one another, how to debug them, what not to do, what to do. And that's the goal of Linux from nothing. So to reiterate, we're going for video form, still entertaining, concentrated Linux knowledge. That's the goal. So with that, I really like your comments. Don't stop making comments telling me where we can go with this. If you've watched till the end, write Doom in your comments so we can know that you're a true Linux Giga Chad. And we will see each other next week in the new series of Linux from Nothing, Really Basic Edition. And of course, take care.